you. And as the last speaker before our break, I would like to invite Felicitas Paus, who back then, during the discovery of the W and Z boson, was right at the heart of the analysis. Now, Felicitas is now a professor at ETH in Zurich and also later played important roles in the L3 and CMS experiments here at CERN. Felicitas, please.
Can I get the first transparency, please? Who is manipulating my transparencies here? No, but this is not the what is the first one? Okay, thank you. Good afternoon. It's really a great pleasure for me to be here today and talk about the physics at the proton-antiproton collider, because it was can someone stop this? How do you do? I want to go master the change myself, because it was a very exciting time in CERN's history.
You're happy?
I hope so. Can you stop the automatic movements? Sorry. So. Maintenant, it's okay. Yeah. Merci beaucoup. So, the physics highlight of the proton-antiproton collider was, of course, the discovery of the W and Z bosons. And you see here the first Z event recorded in end of April 1983 with UA1. It was really an exciting time for all of us working in the experiments and at the collider, but also very emotional. And certainly also for those who have been invited to Stockholm in December '84, and you see here, no, there's a problem with this file. I don't want that this thing goes without me touching anything, if this is possible. Sorry that you don't count this time now, huh? Okay, I don't know. So, this we had. I go to the next one. We had already. And now, can I? Okay. Again, very exciting time in CERN's history. W's. Maybe I do it here?
Maybe I use this, and when you say to me...
Next. No, because it's with animations. I have to control this thing, hopefully. I don't know. So what are you doing now? You reload it?
They will change it, and maybe it will be better.
Okay, so you can admire at least a picture of the Nobel Prize. People at I don't know what happened here.
We do the coffee break now. We try to fix it, and you speak after the coffee break.
As you wish. So if you want to wait after the coffee break, I'm happy, and one should fix the problem here with the machine.
Let's break for 15 minutes, come back 10 minutes to 4, and we'll try to fix the text.
Oh, it is repaired now, I was told. So I go on. Okay, it's repaired. So, you see this beautiful picture taken? Yeah, I was told it's repaired in Stockholm in December '84. So, a little bit of history, because I would like to recall what were the big physics questions, the big challenges in the mid and 1970s. Recalling a bit what was said already, the formulation of the electroweak theory provided us with this nice relation between W and Z masses. And then after the discovery in 1973 of the neutral currents and the first measurement of the Weinberg angle, one had a prediction of the W and Z masses, as Luigi Di Lella quoted it in his talk given here. 1977, QCD was really applied for predictions of hard scattering processes. The same year, the bottom quark was discovered, and everyone assumed the top quark must also be somewhere. So clearly, if you want to discover the W's on Z, the best machine you could have is a high-energy E plus E minus collider, Therefore, John Adams, at that time Executive Director General of CERN, initiated the lab study working group already in 1976. The worries were that it might take too long to construct lab, and also the worries about the competition from the US in discovering the WCNZ. The same year, Carlo, with his colleague, as we heard, proposed the proton-antiproton collider, and then the execution of this proposal as a project at CERN, we just heard about from Lynn. He did not mention our center of mass energies, but for completeness, I've put it here. On the experimental side, there were many challenges. One, for instance, I show here the cross-section as a function of the center of mass energy. In TV, the proton-antiproton collider at CERN, the Tevatron, and for your convenience, I also added the LHC. You see the total cross-section is very large, and one wanted to access the W's and Z in, oops, here, this is moving strangely. So W and Z in a leptonic channel. So what you had to do is you had to reduce 8, 9 orders of magnitude the rates in order to access these events. And it's clear that was a challenge for our trigger in the experiments. As we heard from Ugo before, middle of the 70s, we did not really know yet if jets are really produced in hadronic collisions. Other open issues were how are the experimental conditions, what were the background at the collider, can we really operate an experiment there? And the other important question was, is a 4-pi detector concept really the correct approach? So the two big experiments at that time, UA1 and UA2 were the two important aspects of the Hadron Collider physics. UA1 was the first multi-purpose 4-pi hermetic detector in particle physics in general. We had a 0.7 Tesla dipole magnet and a very powerful central tracker. It was a big drift chamber, cutting-edge technologies, and really the first electronic bubble chamber, as you could convince yourself also from the first set event I just have shown you. Another thing which was impressive was UA1 was improved in June 78, and only 3 years later, first events were observed with this detector. UA2, on the other hand, was optimized for W and Z detection in the electron channel, so they had no central magnetic field. They also had no muons, but I want to make one remark about their upgrade concerning the vertex detector, because this was really the first incarnation of a silicon tracker adapted to collider experiments. And also UA2 was very fast in constructing their detector and taking data already end of 1981. So here are two pictures. UA1, I'm sure you recognize this gentleman in front of UA1, and UA2 during the construction period. But I want also to mention that the collider offered also other experiments to exploit this new energy domain, namely UA4 measuring the total cross-sections using the famous Roman pots. UA5 was a very large streamer chamber experiment. They only had to measure charged particles. They only had few days, and then they had to roll out because UA2 took over the place in the tunnel. So what was the timeline of our discoveries? This is shown here, again recalling the important dates of proposal and then approval of the proton-antiproton project together with the two big experiments. The first data taking in 81. And then in 82, we had already first important announcement by UA2 on the hadronic jets. We also had a very famous visit of Madame Thatcher at that time. We had the second run-in from October to December, and the first W candidate was identified by UA1 in November 82. So UA2 had a very pragmatic approach how to search for jets in hadronic collisions. Namely, they decided to select the highest ET event and then simply look at the energy flow in the calorimeter, which you see here in this nice Lego plot. You see here the energy, I don't want to use this, maybe I can use this. Oops, I'm not mastering this thing here, I'm sorry. Okay, so you see this Lego plot is a very impressive presentation of high-energy jets in proton-antiproton collisions. UA1 first looked at correlations in the tracks and then in the central detector, and then also looked for jets using a jet algorithm in calorimeter cells and also in the central detector. Then when we had this conference in Compostela, end of August, beginning of September, this was really a celebration of collider jets. UA1 then also presented these nice Lego plots, and the first picture of Megatech of two jet events from UA1. I want to recall that this Megatech was an interactive event facility in UA1. It was extremely, extremely useful to analyze, to look at data and to understand them, but also, I can tell you it was fun to look at this event picture at the Megatech, as Carlo knows. So this famous visit of Madame Thatcher, you see here a picture. When she was at CERN, she also asked the DG, Herwig Schopper at the time, that she wanted to be personally informed about the W and Z discovery before the public announcement. And since we had in UA1 and UA2 already W candidates, Herwig Schopper could write a letter to her, and he did this on the 20th of December 82, not only wishing her all the best for the new year, but also stating, and I quote, I am pleased to inform you in strict confidence that the results recently obtained point to the imminence of such a discovery. Indeed, a few events have been seen compatible with the decay mode, leptonic decay mode of the W. For the young people who listen to this talk, I want to recall that 1982, we had no internet, we had no smartphones, and we also had no social media to communicate our results. So, continuing with the timeline, in 1983, we had a very exciting January, because by end of the months we could announce the discovery by UA1 and UA2 of the Ws. The third run started in April the same year. As I mentioned already, in the 30th of April, we had the first set registered in UA1. Already 1st of June, we had the press conference announcing the set discovery, and 1 month later, also UA2 announced their discovery. So the W was discovered in the electron channel first. There was this famous Rome meeting where UA1 and UA2 showed their candidates, not claiming that they are candidates, and as Carlo put it, se sono rose fioriranno. You said this, Carlo, there. Then were the famous CERN seminars, middle of January, where Carlo Rubier presented 6 and Luigi Di Lella 4 candidates of their experiments. These were still preliminary results, and then over the weekend lots of analysis was done, and a few days later, Carlo was really convinced this must be Ws, and he put it in the following way. They look like Ws, they feel like Ws, they smell like Ws, they must be Ws. And this is what he refers to. You see here the missing transverse energy plotted as a function of ET for the 6th event shown at the seminar, and you see this very nice correlation between those two quantities. And this was also the first time that we used missing transverse energy as a signature for a new analysis tool. So this is a nice W event in UA1 with a stiff track pointing to the electromagnetic calorimeter. And with this picture also you see the advantage of having a magnetic field in your experiment. Mass was determined. And of course, UA2 also used this missing transverse energy signature to select W events, and you see on the bottom the transverse energy of the electrons of these 4 events as W in nu candidates. And this is the famous Lego plot of a W in electron-neutrino decay, and also the determination of W with UA2. And then end of the month, as I said, there was the press conference by UA1 and UA2. And when I look at, each time I look at this picture, actually, I wonder why these gentlemen all look so serious. It was, after all, a very joyful event, wasn't it, Carlo? And Luigi, par exemple. So, then, of course, joyful was also the set discovery. The first set, again, recorded here on 30th of April in Electron Channel in '83. Actually, on the 4th of May already, Marie-Noëlle Minard, she was on night shift for the express line which we had, found this event and immediately transferred it to the Megatech. And this event cost many of us lots of headache because, as you can see, the electron track had a very well measured momentum, 9 plus minus 1 GeV, but the energy was not matching to the momentum measurement. So the interpretation was you have an electron and a very strong Bremsstrahlung. And since this was the first event ever observed, the probability of having just such a configuration was extremely low. Therefore, there were people saying that these are the first indication of compositeness, namely you produce set into electron-electron star and electron star into electron photon. Of course, it was not compositeness, it was just Bremsstrahlung. We had then also the first set in mu plus mu minus, the press conference, and the paper was already submitted on 6th of June. And I show you here the analysis cuts for UA1, selecting the set 0, also to illustrating how simple the cuts were. And at the end, we had 4 events with basically no background. And we could determine the mass, you can see here on this plot, of the 4 electron channel, and we also used the 1 muon event we had at that time analyzed. This is the press conference, and actually a few days later there was this article in the New York Times saying Europe 3, US not even set 0. 5 minutes, okay? So I don't tell you now why they said this, okay? The discovery of UA2 was announced 1 month later by Pierre Dirichlet. Again, the selection cut's very simple and basically no background and a nice Lego plot. Just for completeness, the W's and Z's in UA1 in the '83 data were of course also searched for and found. You see a very nice W in mu out of the 14 events selected, and one nice set into mu plus mu minus out of the total of 5 events we had. So this time of the discovery was really a very exciting time, but I must also tell you there were periods in this time, Carlo, you remember, where we had not much sleep, and this is a gender-neutral statement, this applied to everybody. So after we had this discovery phase, from '84 till the end of the data taking, we thoroughly tested the standard model predictions, and we searched also for physics beyond the standard model. But also this time was very exciting, and I show you 2 examples. The first is that events with jets and large missing energy attracted the attention of many people also outside the UA1 collaboration. And in order to analyze those data, and you see here the '83, '84 data, we introduced the so-called tau log likelihood method, which is plotted versus the jet ET in the event. So you will use the tau likelihood larger than 0 for the events to select W in tau neutrino, and you see here, and the tau decays hadronically, and you see here a beautiful agreement between Monte Carlo and data, a tau candidate, we determined the mass, but more importantly, this was the first test of lepton universality at Q squared equals MW squared. Then we had these nice monojet events, and from L tau less than 0, and of course this was a sample, we looked for new physics, new particles. Unfortunately, all these events were in agreement with predictions from the standard model, so the only thing what we could do at the end of the day, put limits like, for instance, a heavy lepton, or also, to our big regret, on supersymmetric particles, as John very likely might confirm. The other excitement came from UA1 events where we had isolated large PT leptons, electrons or muons, and 2 jets. This is shown here. We had 6 events, 3 in muon, 3 in electron. And when you look on the horizontal line, there the 3-body mass, which peaks at 40 GeV, and the 4-body mass, which peaks at 80 GeV, you could interpret this event as a decay of the W into top and bottom, and actually the solid line is a prediction of a 40 GeV top. So it was consistent, but of course one needed more data, and again, at the end of the day, the only thing what we could do in UA1 and UA2 put limits on the top mass. So at the end, we had not found anything new, but we had made so beautiful measurements of tests of standard model. For time reason, I have to be short now, and I want to show you just a few of them. The first measurement from an oscillation in B0 bar system at the Hadron Collider, I think one has to mention. QCD works extremely well. You see this in this plot. I really absolutely love this plot, really. It's beautiful. Gluons have spin 1. We proved this. A very nice measurement of UA2 in determining the W mass. Also, they could show that Ws and Z also decay in hadrons. We could prove that the spin of the W is indeed 1. And this is also another very nice plot where the mass of isolated mu plus mu minus pairs are plotted, and you see the J psi, the epsilon, and the Z0 mass, and of course many, many more results. To conclude, after the discovery, we really firmly established the standard model at the Proton-Antiproton Collider. We had some hints, but unfortunately no evidence for new physics. What was the lessons learned? The machine background was much less than one was afraid about. A 4-pi hermetic detector with magnetic field is indeed essential to fully exploit the physics potential. A selectivity requirement of 1 out of 10 to the 9 is possible. The trigger worked well. One should also be aware of statistical fluctuation, also should be aware of tails in distributions, and one should carefully about the upgrade projects, and I think these were very useful inputs for the Atlas and CMS detector designs. I would like to express my big thank you to all my friends and colleagues from UA1 and UA2 for contributing to this really very, very rich physics output at CERN's Proton-Antiproton Collider and sharing this exciting time with me. Thank you for your attention and happy 50th anniversary.
Thank you very much, Felicitas, for sharing the exciting story of the W and Z discovery with us. We may have time for a short question, if there is any. Up there, you have a microphone in front of you, please.
So, I was always fascinated by the megatech. When I hear about UA1 and the way the physics was done, can you tell us a little bit how the megatech was used? And if it was just to look at the event, or if it actually, it was used actively for science?
It was an interactive mechanism. So, for instance, we could reconstruct the momentum of tracks to be sure, you could take points off from the central chamber to be sure that this reconstruction is safe. And on the other hand, when we discovered the Ws and Z, and when some people always are so negative and they thought, no, maybe it's not. But each time I had a visit at the Megatech and we showed them a Z or a W event, there was just no doubt about it. You see these beautiful events, you just make a simple cut of 1 GeV-PT, 1 GeV-ET, and the only thing what is left is the 2 electrons, for instance, and maybe a jet. But it's very easy also to convince the community indeed. Because the selection cuts were very simple. We had no complicated analysis. It was not necessary. So now it was extremely useful, and I regret, actually, I was in favor that one continue this at the LHC, but somehow people didn't appreciate as much as some of us did for UA1.
Okay, thank you very much, Felicitas. Again, apologies for the technical hiccup. that we had at the beginning. I propose that we break for tea now, and we should reconvene 10 minutes past the hour. Thank you.